Function notation. In the world of mathematics, like any other form of science or study, we try to have a consistent way to describe things all around the world where we could defy language. And so a long time ago, mathematicians, I should say, came up with a writing convention. And in this, what they did for this writing convention is that they came up with a language in order to make sure that whenever anyone needed to describe a particular equation or a particular function or a graph, that we wrote it all in the same way. This is function notation. So let's read it from left to right. It says f colon square brackets 2 6 arrow r comma f of x equals x squared plus 7. First thing you might have noticed the way I said f of x rather than saying f bracket x close brackets. We usually read this as f of x. That is because what we're trying to say is that it's a function where the main variable in it is x. That's what it means. So that f is for the word function. So this is a function of x. Now, we don't have to be limited to f's. We can use any other letter we like. So the little f on the outside is simply the name. So it's the name of this particular function that we're using. So you'll find f is the most common. If we have multiple different functions, we'll use f, then g, then h, usually j, which don't always use I, but honestly you could use whatever you like. Especially when you do physics examples, we end up doing things like using v's and all that kind of business. This little duva, the little 2 to 6, well, that's the domain that we are using. Now you might think, quite rightly, you might think, well, the arrow to R would imply that that's the range. Actually, it's not as simple as that. It's a bit of a silly thing, but what it's saying here is that all of the y values, or the range, is a subset of this value. So it's just saying that the range is considered to be part of all real numbers, which makes a lot of sense, unless we're dealing with strange complex numbers or something like that. All it's saying is that, oh, by the way, guess what? The range, which I'm not going to tell you, but the range is considered somewhere on the number line. Thanks, maths. Really appreciate it. So when it comes to this function notation, then the last aspect is the fact that this bit here is simply the equation. So this is the rule, if you like, of that it fits to this function. So whenever I talk about f of x in this particular example, I am actually referring to this equation, which is x squared plus 7. So why do we go about doing all of this? Well, the reason why we go about doing all of this is that we use this particular notation to save us time in writing questions and all that kind of thing. So for instance, you'll see here, it says f brackets 2. What that is saying is, could you kindly substitute the number 2 where it says x? In other words, what is the function given 2? So all I need to do here is go 2 squared plus 7. So that's going to be 4 plus 7 to be equal to 11. Easy as that. fx plus 2 means that I'm substituting every time I see the letter x with x plus 2. So this becomes x plus 2 squared plus 7. Now I could leave it like that, but we may as well tidy things up here. So we get x squared plus 4x plus 4 plus 7, x squared plus 4x plus 11. So we substituted that in there. Now you'll notice here for this one, it has 2f brackets negative 3. You'll notice there that the 2 is on the outside. What that is saying is I'm doing 2 times after I've substituted x with negative 3. So in other words, I'm going to put 2 in brackets, And then I'm going to just write negative 3 squared plus 7. 2, 9 plus 7. So it's going to be 2 times 9 plus 7. It's going to get me 16. And that's going to be 32. To graph the following, you may want to use your CAS or Desmos to assist. We've got the function h of x is equal to negative 3 fx minus 2 minus 5. So we could do exactly that. So in the main, what I'm going to do is I'm going to go and get the old keyboard out. You'll notice here under Math 3, there's a button that says Define. This is the function I do to be able to define or to set a particular equation as a letter. So I'm going to write define f x equals x squared plus 7. So what does that mean? It means every time I do f brackets and put any number in there or any letter, it does everything for me. You might notice there it says x plus 2 squared plus 7. Well, if I don't like that, I can type in the phrase expand, ants, and it will expand it for me. So why this is useful is that if I go to menu, go to graph and table, clear out the nonsense that's already here, if I type in f of x, the graph will remember that I mean that original function. I'm just going to press the 4 arrows here because clearly I was doing some other graph beforehand. And what it's done here, and now you'll notice here it hasn't come up. That is because it's x squared plus 7. So it's actually going to be hiding up here a little bit. So what I'm going to do is I'm actually going to click and drag, and there it is. There's our little friend. What I might do though, I might go and just increase the scale. Go y maximum, we'll make that a 20, we'll make it a negative 20 here, 20, negative 20. I'll make the scale 2, make the scale 2 here, and so there we go, there's our graph. So now what I can do is I can actually go and alter the graph accordingly and go negative 3 times f of x, x minus 2 minus 5. Now notice here nothing's come up yet because what's happened is that it will have gone, it's actually probably very, very far away. So what we can do is we can zoom out. Let's see if we can find, oh there it is, right down there at the bottom. So we can go and wonder what exactly has happened. We've known that it's stretched a bit. So it's a little bit narrower. So if I drag that up, you'll notice here it's narrow. It has gone upside down. It's become narrower. It's moved down. And it's actually gone across. It's moved right. So if I was just to adjust the x scales here, if I just made that 5, made that negative 5 for just a moment, and made that a scale of 1, have a look there. It's actually moved across by 2. So having that x minus 2 here means it's moved across to the right by 2. And interestingly, you'll notice there that it's, now you might think, oh, well, probably it's gone down by 5. Has it though? Well, remember up here it was 7, so it was x squared plus 7. So let's find out where it actually ended up. Now the great thing is I can go to the max function, and I can select this graph, and it'll tell me where the turning point is. It says negative 26. So what's it done? Well, negative 26. Now, just as a reminder, the turning point of that first one is at 7. You'll notice there it's a negative 3 at the front. So what it's done to that turning point is it said, all right, 7 times negative 3 is negative 21. Then we move that down by 5. So it's actually now being gone down by negative 26. you don't need to do this so much right now in this particular chapter, and you might be wondering, oh, what is he talking about? Well, when we get up to transformations, which is the last topic that we will look at with maths methods, we'll be coming back to this idea. But I thought it would be rather useful to be able to show you how to do this on the calculator.